let's get started. Today we're going to be talking about these folks climbing up to the top of this doohickey right up there. These people climbing up to the top. No, we're not going to be doing that. We're going to be talking about Kafka Consumer Groups. We'll be talking about it in a way that's less talk and more pictures and code. Some of the things that we'll cover along the way are the differences between independent consumers and consumers, message keys and partitions, order guarantees, how a consumer group coordinates who's doing what, when, etc. This TV show assumes some familiarity with Kafka consumers and producers. If you don't have that already, it might go okay for you. If not, there's also some other videos about consumers and producers if you're so inclined. The source for all of this is going to be available here, and I'll try to include some links, that's clickable links as well. Anyhow, it's assuming that you're seeing this video, or if you'd like to see the show notes and more description about what I'm showing you, go to this URL right here. It will include links to the GitHub source, etc. Because we're really going to be talking a lot more in the demo than here. And here we're going to go through some pictures. So let's start with this picture. Imagine, if you will, topic A. It has a single partition and a single consumer. That current offset is at this message with the key represented in yellow. If we had add another consumer, no coordination between the two. They're going to have different offsets. Most likely, which means they're going to be reading and from the topic, and they'll be at different locations within that topic as they read along. There's no coordination between it when they're independent. So here's an example of independent. Now, quickly, let's note something here that you might have seen in other diagrams, and that is the differences between messages as they're represented in a topic. You might see it with different colors. And a note about this is that what these colors are intended to represent are maybe messages with different key values. So yellow might have a message key with CDE, for example. For those of you that are sharply watching, it's the middle one here. Now, this doesn't really matter in these slides. We're going to keep it higher level than that, and we'll show in the demo later on some examples of this. But don't stress out about different colors for now. Independent consumers. Now imagine it has two partitions. Again, each consumer is going to act independently. So in these cases, if they have different consumer group IDs, again, we'll show you this in the demo, they are going to read independently of one another, and they'll read from each partition on their own. But what happens if we start to ask or set an actual consumer group? So if each consumer has the same group ID, 1, 2, 3 in this case, now each consumer will be assigned a particular partition as represented in this diagram. This is key to understanding consumer groups. And as you know, consumer groups are the basis for many more things within Kafka, like Kafka Streams and Kafka Connect as well. So you need to understand one consumer per partition. What happens if we add a third consumer? Just this quick side note here. Is that wasteful? Or could you consider this a hot standby? Now, people do this. They might be running for a while and they're consuming their partitions, and consumer 3 is just sitting there idle. Is it wasteful? Well, I mean, in some cases you could consider it wasteful, but what happens if consumer 2 dies? Consumer 3 will immediately start picking up and start reading. So, I mean, it's up to you. If you want that hot standby ready to go, it's something that you can do. But as this hopefully shows in the diagram, running 3 consumers against a topic that only has 2 partitions might be wasteful. Or it might be planning for resiliency. That's up to you and your particular style. Let's keep rolling here. If you have a topic with 3 partitions and 2 consumers, what's going to happen? Well, again, we'll show this in the demo, but it's going to look something like this. Each partition will be assigned to a particular consumer. You won't have one consumer rotating between multiple partitions. This matters. Okay, so you'll see this assignment in the demo later on. Third example, what happens if it's easily divisible? We'll see this example as well in the demo, where each consumer will have the same amount of partition reading or processing workload as shown in this diagram here. Consumer 2 reading from partition 2 and 3. So let's do this. Let's get out of these pictures. Let's get into a demo. And we're going to show a demo from IntelliJ. I'm going to switch over here in a second. Again, all the source code for what I'm about to show you is available at this repo here. And wherever you're reading this, I'll include a link for these, or hopefully I'll try to include a link up here too, that you can download all these examples if you're interested in running it. So hang tight. I'll be back in a second in IntelliJ. Okay? If I can flip this doohickey around. There we go. And we're back. This is where you can find all the source for the magic that's about to happen. Again, this should be in the TV show notes. Let's get to it. I'm going to open up Terminal and start up Zookeeper. And I'm going to start Kafka. So you'll see we've got 3 tabs here going between. Let's make sure everything's okay. So by doing that, we'll do a canary test of listing topics. We have, as you saw from that output, no topics. So Zookeeper, Kafka, no topics. Let's open up IntelliJ, where I have imported the source project that I showed originally, the GitHub file. This isn't anything special. It's just examples of consumers and producers. And we're going to use these existing examples to dive deeper into consumer groups. So again, this video is a video that's been created after I created videos for both consumers and producers. Wherever you're seeing this, there should be links to these other consumers and producers as well. In fact, let me show you real quick. So here's an example of the consumer. Here's an example of the producer. This has all the links and more background on it. So this assumes you've already gone through that. You've imported it. It shows how to import into IntelliJ, all that. Okay? Great. So let's keep going. Let's start off by creating a topic. So I've got this ready to go. We'll create a topic with 2 partitions, calling it example topic. Nothing special. Let's just make sure we'll list that topic, and we've got example topic. Okay, that's the default that we're using in our consumers and producers. So let's start first with the consumer. And you'll see that it's configured here to read from example topic. And the group ID, which will be changing throughout this demo, is still the default of Kafka examples. Let's start this up. So I'm going to right-click on this and run it. Now, I'm going to show you running 2 independent consumers. Remember those pictures from the slides? What it looks like for 2 independent consumers? You'll see up here in the top, to allow that in IntelliJ, in case you're wondering, is if you edit this run configuration and you check the allow parallel run, this will allow you to run more than 1 instance of Kafka Consumer Example, and we're going to need to do that. So let's show running another consumer, but we'll assign it to a different group ID. In other words, this is going to be running independently of that already running Kafka Consumer. So we'll fire that up. You'll see that the outputs from both of these consumers are interesting in that they're going to assign both partitions, setting newly assigned to both of the partitions in that topic. Right? Some other interesting things too along the way. Notice that we're contacting the group coordinator. That's probably something that you'll get into a little bit more deep, or it's more deeper. It's more advanced how this all works. But we've got 2 consumers running. Let's take a look at this producer. Again, this is the default. It's going to be producing messages with a key that's going to be dynamic. We're going to do some inserting of 1, 2, 3, etc., and the value of the value. Let's just keep it by the defaults and let's run it. Let's see what happens here to both of our consumers. Move this up a little bit. And what we should see here is that each consumer is processing independently. So now I'm over here in the next consumer. You'll also notice that it's out of order. We'll talk more about that as we go on. But this is because it's happening. It's really accentuated because of two reasons. One, we're creating dynamic keys, and also because these consumers are consuming from two partitions, ordering is not guaranteed. Now that's a little bit of a highlight of where we're going, but we're just starting off with the same pictures as we saw in the slides. Two independent consumers, one producer, and we see the differences there. Now what happens if we change this? What happens if we make it all part of the same group? So let's kill these consumers. We can kill this one as well. And let's say that we're going to fire this up with an idea of Kafka example 3. So we'll start running that. Again, this is the group ID. We'll run another one. Same group ID. So now we're going to see something interesting. We're going to see that the group coordinator was contacted. It's going to revoke any previously signed partitions because we now have the same group ID. It's going to be rejoining this group, and it's going to be assigned some partitions. Topic 0. If we go back to the other consumer, we'll see something very similar. Revoking as well as assigning now to the other partition. So remember that picture again. Each consumer now is going to consume from its assigned partition, either 0 or 1. So now if we fire up Kafka producer again, we should see this, I would imagine, evenly distributed because essentially the keys are randomly generated. We're going to see this round robin. So we've got 5 here from one consumer, and the other one, if we scroll down, also has 5. Notice the messages here might look out of order because these keys are dynamic. Again, we'll show you this a little bit more in detail later on. But one thing that might be interesting is, remember when we talked about either wasteful or highly available? What happens if we fire up a third consumer here? What the heck? Let's do it. Same thing. It's going to revoke all the partitions. So if we go through these from all existing consumers, interesting, huh? And then reassign. Now at the time of this demo, we're in Kafka 2.3. Anyhow, back to IntelliJ. We now have consumer. This consumer is assigned nothing. Whereas these consumers, I got my fancy pointer a little too early, is 1 and 0. So if we fire these producer up again, what do you expect to happen? If you guess this consumer will receive some data, and this consumer will, and this one will receive nothing, you were right. But let's show what happens if we kill one. What happens then? Now we're going to wait a little bit. We're going to wait a little bit based on a couple of configuration variables to start the group coordinator again, and there it is, to revoke and reset. So now this previously idle consumer has a topic, the partition assigned of 1, and this consumer, again, it goes revoked and reassigned, is reassigned the same partition actually in this case. Now if we run it, we should see both consumers processing. So this is all built into Kafka itself. There's no other cluster that we need to be running to achieve this effect. This effect of another consumer just picking up where the other one left off. Now you might be wondering about that pause in between, and in between the detection of a consumer going down. I would point you to the documentation for Kafka or Confluent as well, and look up heartbeat. And what you should find eventually is this heartbeat interval millisecond. And you'll want to read about that as well as the combination with session timeout millisecond. Now you can set some defaults or you can override these as well. But check that out if you're interested in learning more about the pause in between those two consumers. All right, so another thing here, let's keep going. Let's kill this consumer. Let's kill this consumer. And let's start up let's start. What happens when we start up a brand new consumer? Even though the consumer says that, or is, excuse me, can be configured here for, that's producer. If we look into consumer, even though the consumer is configured to read from the very beginning, what's going to happen if we restart this consumer? We saw when we ran them independently in the very beginning that it processed everything. Now, because Kafka is already aware of the consumer group, Kafka example 3, and it is storing the current state of how many messages this has been consumed, we won't actually read from the earliest. Instead, as I'm attempting to describe, Kafka is already aware of this consumer group. And we can see this. This is a different topic entirely. But if we list the topics now, we should see this internal topic designated by the underscore underscore. And that is where Kafka is storing the current location, the offset of this particular group. So far, so good? Okay, cool. One of the other things that I wanted to show you here is the idea of ordering and how a key matters too. So let's go back to the producer. Let's fire up, what the heck? We've got a 2 partition topic. Let's fire up another consumer. And we couldn't really see it that well with the defaults producer. I'm going to modify this and we're going to change the keys. Let's see if we can show ordering here now. Again, it's Scala. It's no big deal. It's so simple that you'll be able to read it. I believe in you. Let's change the key here to red. What happens? So in other words, it's going to be set for every 10 of the messages that come through. What do you expect to happen when we look at these two consumers? Before we saw it evenly distributed. What do you expect now? If you guessed only one of the consumers will see messages, as shown here, and in order, you would have been correct. This highlights better, I think, the idea that each consumer is assigned to one partition. It's much more clear now if we have the same message key for each one of the messages that we're sending, rather than the old dynamic keys. So let's run this again. The same consumer got it. But I bet you, remember, this is only a 2 partition topic. I bet you if we keep going here, eventually these keys and the designation of where it lands in the partition will land up in the other consumer. Red, blue, and we may have gotten it here. We did. The other consumer got it. So now you might recall, or if you don't, I'll just describe it quickly. The way Kafka determines where to place a particular message based on the key is it runs by default the murmur2 hash on it, and then it will mod that based on the number of partitions. So internally, that's how each one of these messages is determined, what the location is determined. And as we're seeing, it may not be round robin between the 2 partitions, partition 1 and partition 0. Cool? Yeah, all right. So let's keep going. There's a couple other things here real quick I think is relevant. We'll kill all these examples and then we'll wrap up. And I just want to show you, recall back to some of those pictures about what happens between when you've got different amounts of partitions and consumers. So let's let's create another topic. Let's create it with 3 partitions. Again, I encourage you to experiment like this to get a better handle on it. Let's create it with 3 partitions. We'll have 3 topics now with the internal. And if we come back to the consumer and we go to, what did I call that again? We call that example topic 2. What happens now if we fire up two consumers with 3 partitions? I'm guessing you'll probably already know. One consumer gets 2 partitions. The other consumer just gets 1. Right? What happens if we fire up another consumer? Each consumer should get 1, right? Let's see that in action. There's 1. There's 1. There's 1. Cool, right? And now let's stop all these again. Let's create a 3rd topic. Let's create it with 4 partitions. I think you could probably see where this is going, right? Ooh, better call that something else. What was that topic name? Example topic 3. Let's fire up 4 of these bad boys. The idea, if it's not painfully obvious by now, is that you have to be aware of this mapping between consumers and partitions. It is essential that you get that, not only for ordering, but understanding how you can either design the scaling out of consumers that are working in coordination, or as previously shown, wait a minute, did I fire up 5 of these? Oh my God, it's crazy. It's crazy talk. Anyhow, each one of these should have 1 partition, right? I think you're getting the idea. If not, leave some message or comments here for me, and I'll try to update this or make it more clear to you. It's essential that you understand the scaling out through consumers and consumer groups is how they're assigned, and it is, as you can see, a requirement to understand the amount of partitions you have in the topics that you're consuming. So that wraps up the demo here. I'm going to get back to just a quick little ditty for you on some links and for more information. So hang tight. I'll be right back, okay? So let's recap. Why consumer groups? Well, here's a couple of reasons for you. One, you want to scale out. You want to scale out in a way that there's coordination between consumers. We showed how to do that. So that's one reason why you would consider consumer groups. Another one is resiliency. No single point of failure, as they say in the biz. You might want to design your system to handle failures and expect failures. What happens if a consumer goes down? We saw other consumers can pick up the workload after a rebalance. This is, by the way, a differentiator for Kafka. As you know, you've got other choices out there for stream processing and horizontally scalable frameworks, cluster computing. What was interesting to me as I learned more about this was, you don't have to run a separate cluster. Yarn isn't involved. It's kind of nice if you think about it. There's no separate cluster needed for this coordination. Finally, it's absolutely critical that you understand consumer groups and the mechanisms behind that if you want to go further in your Kafka journey and learn more about Kafka streams and Kafka Connect and KSQL, because this coordination between workers is built upon consumer groups as well. So that is the show. Again, the source can be found here. If you have any comments or questions, leave it wherever you happen to be receiving this TV show. And thank you for your time, and hopefully you found this valuable. And again, if there's anything that you are questioning or comments, anything that you can, help me help the message here, let me know, and I appreciate it. So thanks. Have a good one. Bye-bye.